A spanning tree is a tree that connects all of a graph's vertices. A minimum spanning tree is used for a weighted graph, and it is the spanning tree with the smallest possible total weight. And to find the minimum spanning tree, we're going to be using Kruskal's algorithm. So step 1 of Kruskal's algorithm says to find the edge with the smallest weight in the graph. And if there is a tie, we can just pick one at random. And then we need to mark this edge. Step 2 says find the next smallest unmarked edge in the graph that does not create a circuit with your marked edges. And if there is a tie, we can pick one at random. And we need to mark this edge. And then step 3 says repeat step 2 until all vertices have been included. The marked edges are the desired minimum spanning tree. For problems 5 through 7, use Kruskal's algorithm to find the minimum spanning tree for each weighted graph. When selecting an edge, mark the edge and record in the order selected in the table. Give the total weight of the minimum spanning tree. Now, because our graph has 4 total vertices, and for any tree, if you have n vertices, you must have n minus 1 edges, which means we're going to have 4 minus 1, or 3 edges that we must select. And according to Kruskal's algorithm, we need to first select the edge with the smallest weight. So that would be AC, which is 17. So we are selecting AC, and that's worth 17. The next highest edge would be 28, which is AD. And then the next highest edge is 39, which is BD. So now all 4 vertices are connected. So this is our spanning tree, and it has a total weight of 84. So the optimal way to connect these vertices is 84.